Hey guys, today we are looking at 5.3, which is all about solve using elimination. So far we've already developed two methods on solving so far, solve by graphing and solve by substitution. So before we hop into what this new method looks like, let's do a quick little recap of what the two we've established already looks like. So I'm going to do the same problem here, the same system, 7x plus 4y equals 2, and 9x minus 4y equals 30. So let's do a quick little recap. Let's solve by graphing first. So for solve by graphing, again, we're going to graph each of these two lines, just like we did back in chapter 3. And then wherever those two lines intersect is going to be our solution to the problem. So the unfortunate thing here with this system is that neither of my two equations are given in slope-intercept form. And neither of them are set up nicely for kind of our BOOP method or intercepts form. So I'm going to have to start with solving each of these for y so that I can put it in slope-intercept form. So you can see here, I'm just going to designate a different color pen for each of the two equations, blue for the bottom and red for the top. I'm just going to go ahead and start by solving for y in each of the two equations. So over here in red, the step that I'm doing first is I'm solving for y. I'm going to start by subtracting x on both 7x on both sides. So I'm going to move that x term over to the left. And I'm just to save myself some time, I'm going to do that step initially as I rewrite it. So if I subtracted 7x on both sides to move it over, my next step would be 4y equals negative 7x plus 2. I just subtracted 7x on both sides. So then to get my y value all the way by itself, I have to divide through by 4. That gives me y equals negative 7/4 x plus a half after I reduce. Now I'm going to do the same thing with my bottom equation in blue. Here, again, I'm starting by moving my x term on the other side. So that gives me a negative 4y equals negative 9x plus 30. I divide through by negative 4 in all three parts of my equation. That gives me y equals, is going to be now a positive 9 over 4x minus, this ends up being 7 and a half. 7, or if you want to write it as a fraction, doesn't really matter, 7 and a half. Or 15 over 2 if you want to leave it as a mixed number. But since it's my y-intercept and we're going to have to graph that as one of my points, then I'm going to just leave it as 7.5. So not ideal in this case, because if you look at both of them, both of the y-intercepts are fractions. But just for this problem in particular, we're going to just go ahead and plot them as usual. I know usually, and during in the section where we talked about solve by graphing, I said you would have to find nice coordinate points, but just in the sense of saving ourselves some time, let's go ahead and just plot them as is. So I'm going to start with my blue one first. That one has a y-intercept of negative 7.5. So I'm going to go down here to between negative 7 and negative 8. That point right there is negative 7.5. And then my slope is 9 over 4. So from that point that I just plotted, I'm going to have a rise of 9 and a run of 4. So I'm going to go ahead and count up. Now be careful on this because we're counting from a half up whole numbers. So going up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1, 2, 3, 4 is going to be right there. So I'm still, again, partway between two of them. In this case, it is at 4, comma 1.5 would be that point. I'm going to go ahead and grab my ruler, get it lined up as best I can, connect my dots. And that is our first line. Repeat the process over again with my red equation. My red one, which is just barely off the page there. My y-intercept is positive a half. So right here between 0 and 1. And then my rise over run is a negative 7 over 4. So again, that could either be negative 7 over 4 or 7 over negative 4. And remember my slope, when it's negative, either my rise over my run is negative, not both of them. So I'm going to go ahead and just say, let's go down 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4. That's this point right here. Once again, I'll go ahead and grab my ruler, get it lined up between my 2 points, connect the dots to see where they intersect. And it looks like, if my points are correct, it actually does land on a nice point here, right here, where my 2 lines intersect. That looks like 2, negative 3. 2, negative 3. I'm going to go ahead and now do that using substitution. Same problem, just a slightly different setup here. So now, same equation, but I'm going to do this using solve by substitution, which is what we did yesterday and on Wednesday. So for this one, I have to start by getting either my x or y by itself in one of my 2 equations. Now, looking at this, there's not an easy way of doing this. There's not going to be a nice number that works out nicely for us because, you know, all of my variables have coefficients on it. So I'm just going to say in this top equation, I'm just going to solve that one for y. I'm just going to make that decision because that one has a small-ish number and it's positive. So I'm going to go ahead and do that. So right over here, I'm just going to solve this equation for y. Again, I'm going to start by getting my x term away. Right, so I'm going to say 4y equals negative 7x plus 1, nope, plus 2. And then when I divide by 4 all the way through, which we already had this, I suppose we could have just looked at the previous problem since we already did this work. We knew what y was equal to from that previous problem. We know y is equal to negative 7 over 4x plus a half in that top equation. So just like usual with substitution, I'm now going to take what I know y is equal to in one of my 2 equations and substitute that for y in the other equation. It always has to be the other one. So I solve the top one for y, I have to plug it into the bottom equation for y. So when I do that, I'm just going to do it over here on the left side where I've got some space. I've got 9x plus 4 times negative 7 over 4x plus 1/2 equals 30. So all I've done is just substitute that y value with negative 7 over 4x plus a half. So now I have to distribute my 4 into both of these 2 terms. My 9x does not change. But now, when I multiply 4 by negative 7/4, the 4's cancel out, and I'm just left with negative 7 and the x. 4 times a half, or half of 4, we know that that's positive 2. Sorry, this I copied down wrong. I'm glad I caught this here. This is supposed to be a minus 4, which means this turns into a positive 7x, and that's a negative 2, right? Negative 4 times negative 7 over 4 becomes a positive 7x, and then negative 4 times a half of negative 4 is negative 2. That still equals 30, and now actually it does come out to be a little bit of a nicer answer. We had to deal with fractions for a little bit, but at least now we've got 16x minus 32, minus 2 equals 30. I'm getting ahead of myself a little bit. I add 2 on both sides. I get 16x equals 32. So I divide by 16 on both sides to get x equals positive 2. So I've got my first solution, my first part, positive 2. Now that I have that, I'm going to take this positive 2 and plug it back into one of my 2 original equations. So I'm going to take this positive 2 and I'm going to plug it into either the top equation for x or the bottom equation for x. I'm going to go back up to the top one. Again, it was a little bit easier to work with my y values up there. So when I do that, again, here I'm going right here. 7 times, we just established that my x value is 2, plus 4y equals 2. So continuing along there, that's 14 plus 4y equals 2. Minus 14 on both sides to get my y term by itself. Give me 4y equals negative 12. So I divide by 4 on both sides, and I end up with -3. Which is good because that tells me 2 comma -3 x comma y should be my solution, which matches what we got for solve by graphing. So that means we probably did something correctly. 2 comma -3 is my correct solution. But I don't know about you guys, but both of those were horrible to try and go through and do. I mean, it's taken us 10 minutes to get through this first problem doing those 2 different ways. So what we can do, and the kind of the unfortunate thing is both of them were not, like, neither of them had y by itself or x by itself. They were not set up nicely for substitution or for solve by graphing. We had to do a lot of work before we could start either of those 2 methods just to be able to use substitution or just to be able to graph it. So what we want to do here, what we're going to do is a third method called elimination. And elimination is taking kind of the idea of substitution and just applying it in a little bit of a different way. So we know if we're working with an equation, if we were solving it in any of the steps we've done since the beginning of the semester, or the school year, if we're trying to solve an equation, we're allowed to do something to both sides of my equation as long as it's the same, right? Here in this very simple equation, x minus 6 equals 2, I know that I can add 6 on both sides of my equation because that's going to keep that kind of virtual scale balanced as long as I'm doing the same thing on both sides. Now, in substitution, we realized that we could have things that are equal to each other but look different, and then we could go ahead and use that to our advantage, right? In the substitution problem like I'm showing here, we know that the 2 things that I have boxed in the red triangle or the red rectangle here, 2x minus 3 is equal to y, and even though I'm dealing with things that look different, they're equivalent to each other. So I know that I could substitute those between my 2 different equations. Elimination combines these 2 concepts together and lets us take 2 things that we know are equal to each other but look different, and I'm still adding that on both sides of my equation. So what I'm doing here, the 2 things that I have boxed in there in the rectangle, in the red rectangle, I know those 2 things are equal to each other in my top equation. And again, since we're dealing with a system, if it's equal to each other in one equation, it also has to still be equivalent in the other equation. So what I do is I take these 2 things that I know are equal and I add it on both sides of my other equation. But I'm strategic. I pick which one I want to put on either side. It's not going to help me to just add 2 on both sides of my bottom equation. It's not going to help me to add 7x plus 4y on both sides of my equation. I kind of pick and choose what I want to do on each side. Because if you notice here, when I actually go through and do this process, if I added the red box, the top red box on the left side to the left side, if I added the right red box on the right side, I end up with 9x minus 4y plus 7x plus 4y equals 30 plus 2. And as soon as you start collecting up your like terms, you have x's with x's, y's, I'll do a different color here, y's with y's on the same side. You can see pretty quickly the y values, I've got positive 4y and I've got negative 4y, they're going to cancel out. And I end up with 9x plus 7y, 9x plus 7x, which is 16x, equals 30 plus 2, which is 32. And holy cow, we skipped a whole lot of steps. We got all the way to this bottom step in blue, avoiding all of that extra work. That's awesome. So what we want to do is continue utilizing that. Now, from here, we still have to finish up the problem if we're going to solve it using elimination. So I still have to divide by 16 on both sides to get x equals positive 2. And then I still have to go back to one of my 2 original equations, taking that 2, plugging it in for x in my top equation. So 7 times 2, I'm going to fly through this one because we've already done this. 14 plus 4y equals 2, minus 14 on both sides. 4y equals negative 12. So when I divide by 4 on both sides, we get that y is negative 3. And just like that, with a whole lot less work, we get our solution. Now, the reason that works, the reason that worked out so nicely, is because you look at my coefficients in my 2 equations. my y value had the exact same number attached to it, but one of them was positive and one of them was negative. So that when we added those two equations up, my y values canceled each other out, and I'm just left with x. So that's kind of the tricky part of elimination. The only way that this works by just adding them up going down is to make sure that for one of those variables, the numbers match, but one's positive and one's negative. So let's take a look at a couple more examples here. So for practice number 1, we have 2x plus 3y equals 20, and negative 2x plus y equals 4. So for this one, you could do solve by substitution, right? That bottom equation wouldn't be too bad to get y by itself, but especially because we should recognize here my 2x values. This is a positive 2x, and this is a negative 2x. So if I was able to do elimination here, those two would cancel each other out and just leave me with my y values. So I'm going to go ahead and do that. Now, we don't necessarily need to rewrite our equations as like one big line right away because of how we're doing elimination. We can just kind of add up like long addition type stuff because all of our like terms end up being stacked over top of each other anyway. So if you just add up going down, my 2x and my negative 2x makes 0x, so they cancel each other out. My 3y and my y make a positive 4y, and then 20 plus 4 is 24. And just like that, you have a super simple equation to give me my first solution of positive 6. We know right now already that y is positive 6. So from here, just like in substitution, I still have to take this first solution, my first variable, and plug it back into one of my two equations for y, so I can solve for x. Here, even though y is by itself in that bottom equation, I'm actually going to plug it into the top one because it's a positive x, and I'd rather deal with positive x values since that's the one I'm trying to solve. So I'm going to go ahead and plug that into that top equation. 2x plus 3 times, we said 6 was my y value, equals 20. So 2x plus 18 equals 20. I'm going to go ahead and subtract 18 on both sides to get 2x equals 2. So when I divide all the way through by 2, I get x equals a positive 1. Positive 1. So in total, or I guess in summary, 1 comma 6 would be my solution. Positive 1 for your x value, positive 6 for your y. Now that is super easy, and obviously I'm giving some easy examples first, some simple ones. But even the ones that are a little more tricky are still not too horrible once you get the hang of it. So let's take a look at the other practice problem we have here, practice problem number 2. The issue we run into here, if we look at our coefficients, my x values don't match, my y values don't match, right? 5 and 7, and then negative 4 and negative 2 do not match up. And we need those coefficients to be the same, but one positive and one negative, in order for us to be able to do elimination. So what I have to do here is something else I know I'm allowed to do in an equation. I know I'm allowed to multiply in my equation as long as everything in that equation gets multiplied. So what I can do here is multiply one or both of my equations by some numbers to make my coefficients match up that perfect relationship that I want. So it's going to be a little bit of a skill of recognition of which one is the easiest or which method is going to be the quickest to get you your answer. Here I'm trying to figure out what's going to be easier to get my numbers to match up. So you have to ask yourself, is it easier for my 3 and my 5 to get multiplied by stuff to get to be the same number? Or is it easier for a negative 4 and a negative 2 to match up and be the same number? Now in this case, it is far easier to multiply negative 2 to get it to turn into a 4. Right? I could just do that single multiplication in this case to turn a negative 2 into a 4. I could just multiply it by negative 2 and make it positive 4. Where if I was looking at my x values, I would have to multiply both of them by something in order to turn them both into like a 15. So because of that, I'm going to choose to take this entire bottom equation and multiply it by negative 2. Because again, I want my coefficients to be the same number, the same digit, but one's going to be positive and one's going to be negative. So when I multiply that bottom equation in my system here, my new system becomes, I'm just going to rewrite the whole thing, 3x minus 4y equals negative 5. My bottom equation becomes negative 10x plus 4y equals positive 12. So now that I have that first step done, I have my coefficients for y that match up. One's positive and one's negative. So now I can go ahead and just add up going down. Negative 10 and positive 3 is a negative 7x. My y's cancel out. One positive, one negative, 4. And then my number over here, negative 5 and positive 12, is a positive 7. So, and once you get that setup done, we can see that x equals negative 1. That's my solution for that first one. From here, just like we've always done, we're going to take this x value, plug it back into one of my two equations. Here, I'll just pick the top one, because why not? We're going to go ahead back and say, all right, well, 3 times negative 1. Whoops, I forgot to switch my colors. 3 times negative 1, which is my x value, minus 4y equals negative 5. So then from there, 3 times negative 1 is negative 3. Nothing else about the equation changes yet. Add 3 on both sides. We get negative 4y equals negative 2. So when I divide through by negative 4, we actually end up with a fraction, but 1/2. Still not bad in terms of fractions. So negative 1 comma 1/2 is my solution. All right, so I know I have a couple more problems on here that are the you try section. I usually would do those if we're doing the notes live, but I can see it's already a 22-minute video at this point, so I'm going to go ahead and stop there. If you want some more practice problems for solve by elimination, feel free to do these, or we can save these. Like if you're really struggling and we've gone through stuff from the notes, we've gone through questions from the homework, and you still just want some more practice, we can come back to these problems and work through them together. But otherwise, that is all I have for 5.3. Your homework for what you guys should be working on today is page 251, 4 through 20, just the evens. As always, if you guys have any questions, if you have concerns, thoughts, hopes, dreams, ideas, any of that stuff, feel free to reach out and let either myself or Mrs. Smith know. And we'll talk to you soon. Have a fantastic day.